Hi, I'm Yufei, a second-year PhD student at the UC Irvine. Today, really excited to share our work on inference-time alignment. So, as you probably know, language model needs to be aligned to be useful. So, if you ask the model, how do I know if my house has a water leak? Instead of seeing a bunch of similar questions, probably you want some actual useful information. And a good model should refuse to answer harmful questions. And when it's trying to answer some complicated questions like math, it should provide a detailed reasoning steps. Currently, these improvements are mostly achieved through post-training, but we were asking the question, do we really have to train this base model to teach them these new capabilities? Or maybe they just need a tiny bit of nudge at the inference time. So in this work, we will show that instead of expensive post-training, we can align any base model at the inference time using small aligned models. So by this guided decoding, we mean something looks like this. So given a query, we did the base model generation, but occasionally we inject some nudging token to guide the decoding process, like steering the bad answer towards the good answers, and we let the base model continue generation from there. And sometimes we interrupt again, we let the base model generate again, and so on and so forth. So you see, by injecting this nudging token really helps the model to generate more helpful answers. And just by a few tokens, we can prevent this model from answering harmful questions and potentially organize their answer better when trying to answer complicated reasoning questions. So it sounds pretty magical, right? But how can we do this? Given the nature of this method, there are basically two questions we need to answer. So first, during decoding, when should we inject those nudging tokens? And if we decide to inject a token there, what token should we put there? So to answer these two questions, let's think about ideally how do we want to do this nudging thing. And in some sense, the aligned model's output is the goal output we want to have. And if the goal is just to reproduce this, and we have like pretty simple way to do that. So we let the base model generate, but we also have the aligned model as a judge. So every time we let them both generate one tokens, and if they disagree with each other, we just reject the base model's token and insert the token from the aligned model instead. And when they agree with each other, we accept the base model token directly. And here we accept again, and here they disagree again, and then we reject and insert the token from the aligned models. And just keep doing this would basically give you the aligned model's output. But by the way, and the very cool work from AI to show that this kind of disagreement only happens at a few stylistic tokens like however or thank you. But going back to our oracle nudging proposals, although this is not really a valid solution, but it seems like if we can interrupt the generation whenever the base model disagrees with its aligned counterpart, and we just insert the token from the actual aligned model, we would basically get the aligned output. But the problem is, how can we do these two things without the aligned models? And surprisingly, both of them are possible. So for the first questions, we found that when this kind of disagreement happens, correlates very strongly with the base model's uncertainty. For example, you can measure the base model uncertainty using its top one token probability. And if you highlight those tokens whose base model top one probability is less than 0.5 in its response, you will see that these uncertain tokens overlap a lot, actually perfectly in this case, with the disagreed tokens. And if you analyze things at a larger scale, showing the relationship of token agreements and base model uncertainty, and you will get our first findings. So basically, when the base models are uncertain, they usually disagree with the aligned models. And this finding seems to suggest that it's probably a good idea to interrupt the generation when the base model's uncertainty surpasses some threshold. But the second question still remains. How can we get those nudging tokens without actual aligned counterpart model? Unfortunately, we have our second findings. So we found that whenever a pair of large base and aligned model disagree with each other, very often that this large aligned model would agree with some smaller aligned models. And this basically suggests that if the goal is to align a large base models, and probably a much smaller aligned model would be enough to generating those decoding guidance. And this answers the second part of the questions. We just use a smaller model to generate these nudging tokens. And so put it all together, we have our final nudging approach. And here we set the top one token probability to threshold to be 40%. So given the query, we first examine the base model uncertainty. So we see that it's less than 40%. So we inject a token from the small aligned model. And here it's still uncertain. We inject another tokens, still uncertain. So we nudge again. And here we found that the base model top one probability is greater than the threshold. So we just accept the base model token. Here, confident, we accept. And here, the base model is again unconfident. And we just inject the token from the aligned model again. Here, uncertain, we nudge again. So basically, whenever the base model is confident, we let it generate. And when it's uncertain, we nudge. So that's it. Super simple, no training at all, inference-time alignment. But how does it work? So to answer this, we studied 3 different model families and a bunch of tasks covering math reasonings, common sense and symbolic reasoning, general knowledge, and open-ended and safety-related instructions. And we aim to answer 2 research questions. So first, how does nudging works comparing with the actual large aligned models? And we will study this question from 2 different aspects. From problem solving evaluated using accuracy, and subjective answer qualities and safety evaluated by GPT-4. But due to the time constraint, we only cover the first part in this talk. And in the first questions, we discuss is how well does nudging works within the same model families. But still we want to know, can we use, to line a large model, can we use a model from the different model family to nudge these large base models? And you will have more of these discussions in the paper. So first we report the average problem-solving performance of large base, small aligned, nudging, and large aligned. And you will see that first, by comparing 2 models with nudging, it outperforms the individual model significantly. And to understand this, you can think of this way. So to successfully solving all these kind of problems, there are basically 2 different skills: knowledge and formatting answers. And the large base model has very strong knowledge, but it does not follow instructions. And the small aligned model does the opposite. And nudging really combines the strengths of both at decoding time and achieve the best. So in some sense, this is the benefit of having better format, and this is the benefit of having better knowledge. And then we compare nudging with the large aligned models, and you will see that the performance is pretty much comparable, even without any training happening at all. And sometimes it even achieves better performance. And it seems like if we put alignment at the decoding stage, it helps to bypass the potential catastrophic forgetting caused by the alignment tuning. And so far we have seen that nudging works pretty well within the model family, but consider the following scenarios. Say you already have an aligned model family, and then suddenly a new model family comes out. So do we have to train all of this new base model again? Or maybe can we just use the existing aligned model to nudge this new base model at the inference time and achieve and have a stronger and usable model instantly? So to show this, we use Llama 2 to nudge Gemma 2 models. And the first, similar to within family nudging, it's combining 2 models, outperforming them significantly. And more interestingly, just by switching to a stronger base model, and nudging outperforms the previous best aligned model without even fine-tuning. And the intuition is again, so the previous aligned models are very good at formatting, and then this new calm base models have stronger knowledge, and nudging again combines the best of both at inference time. So to summarize, we have seen 2 interesting findings into alignments. When the base model are uncertain, they usually disagree with the aligned models, and the aligned models of different sizes and potentially different families tend to agree at these token positions. And based on these insights, we propose the inference-time alignment approach that combines a large base model with the small aligned models to achieve something comparable to a large aligned models. And it even works with across different model families. So we really think nudging opens up many interesting future directions, and one particular is We have early evidence that nudging can be potentially used for advanced reasoning as well. And please find out more information on our project website. But just to close it up, post-training can teach the base models many things, but maybe they just need a few nudges. Yeah, thank you for listening. You can find more examples and interactive demos and the covered reasoning part as well in our website. Thank you.